If you've ever stood on the shore and watched waves crash endlessly against the sand, you've probably wondered about something that seems almost too obvious to question. The ocean is constantly evaporating. Under the heat of the sun, trillions of droplets rise every second, drifting into the sky and forming clouds that travel across the world. With so much water disappearing into the air every minute, you would expect the ocean to slowly shrink, inch by inch, year after year. And yet, it doesn't. The ocean stays full, steady, powerful, as if it had access to an invisible reservoir that keeps refilling itself. But how? Why doesn't the ocean dry out? To understand this mystery, you need to imagine the planet not as a collection of landscapes, but as a single breathing organism. The ocean is its bloodstream, the atmosphere is its lungs, and the sun is the heart pumping energy through everything. When sunlight hits the ocean, it powers one of the most important processes on Earth, evaporation. But evaporation is only half the story. For every molecule of water that escapes upward, something else is happening somewhere far away. Something that eventually sends water back home. The ocean isn't losing water. It's participating in a global exchange that never stops. Let's start with evaporation itself. Every day, about 1.5 quadrillion liters of water evaporate from the oceans. That's enough to fill over 500,000 Olympic pools every single minute. But evaporation doesn't remove salt. It only lifts pure water vapor, leaving minerals behind and slowly increasing the salinity of the surface layer. So the first clue to why the ocean doesn't dry out is simple. Evaporation doesn't take the ocean with it, only the fresh water. But if only fresh water leaves, then where does all that fresh water go, and how does it return? As the vapor rises higher into the atmosphere, the air cools, and the vapor begins to condense into clouds. Some clouds remain over the ocean and rain back directly into it, returning what was lost in almost the same place it evaporated. But others drift across continents, releasing rain over forests, mountains, fields, and deserts. This fresh water then begins a journey back to the sea, carving rivers, filling lakes, saturating soil, and feeding underground aquifers. And eventually, drop by drop, it returns to the ocean through rivers, groundwater flow, and melting snow. This tremendous, planet-wide cycle is known as the hydrological cycle, and it is perfectly balanced, not by accident, but by the physics of water itself. But there's another element at play, one that most people never think about. The ocean is constantly being refilled from the inside as well. Deep beneath the waves, the Earth leaks water from hydrothermal vents, cracks in the ocean floor where superheated water bursts into the sea from within the planet's crust, and below the seafloor lie enormous reservoirs of water locked inside minerals, slowly released over millions of years. In other words, the ocean is not just filled from above, it is also fed from below. Before we continue, take a moment to subscribe to Curious Horizon if you enjoy discovering how the world actually works. Every week new mysteries unfold here, simple questions with astonishing answers. Now let's go deeper. The ocean doesn't dry out because the water cycle operates like a global conveyor belt, one that never speeds up, never slows down, and never stops. Every molecule that evaporates must, eventually, fall somewhere as precipitation, and every molecule that falls must eventually find its way back to the sea, unless it becomes locked in ice, trapped underground, or consumed by life. But these losses are tiny compared to the overwhelming return flow. The cycle is nearly perfect. Nearly, but not entirely. Over millions of years, the ocean's water level has changed dramatically. During ice ages, so much water became trapped in glaciers that sea levels fell by more than 120 meters. During warmer periods, melted ice returned billions of tons of water to the sea. But these fluctuations aren't caused by evaporation failing or intensifying. They are driven by long-term climate cycles, changes in Earth's tilt, and natural shifts in global temperature. What matters is that the ocean's core mechanism, the balance between evaporation and return, remains intact. But there's a deeper secret hidden in the ocean's stability. The hydrological cycle is not just a natural process, it's a feedback loop regulated by Earth's temperature. When temperatures rise, more water evaporates, creating more clouds. Clouds can either warm or cool the planet depending on their thickness and altitude. When temperatures fall, evaporation slows, cloud formation drops, and more heat reaches the ocean surface. It is a self-adjusting system, one that has kept the ocean from drying out for billions of years. The ocean also benefits from sheer scale. With more than 1.3 billion cubic kilometers of water, the ocean is so massive that even extreme evaporation rates barely make a dent. If evaporation somehow stopped being balanced by rainfall and rivers, if the water cycle broke entirely, the ocean would indeed shrink, but only slightly at first. It would take tens of thousands of years for the ocean to noticeably retreat, and millions of years for it to dry out. In reality, Earth's natural systems prevent that from happening. But what if something changed? What if temperatures rose high enough that evaporation outpaced all return? Scientists warn that in extreme climate scenarios, certain regions of the ocean could become saltier and warmer, potentially disrupting marine life and altering circulation patterns. Yet even then, the ocean as a whole would remain far from drying. The planet has buffers, mechanisms that resist collapse even under immense pressure. Now imagine the water cycle from space. From that perspective, Earth looks like a giant blue marble wrapped in swirling white clouds. You can see the entire system working in real time, water rising, moving, cooling, falling, and returning. It is a closed loop, elegant in its simplicity and unstoppable in its rhythm. The ocean doesn't dry out because it is part of a planetary engine, one that transforms water, moves it across continents, and always brings it back home. In the end, the answer to the question is simple but profound. The ocean never dries out because the Earth never stops giving water back to it. Through rivers, rain, groundwater, melting ice, and even through vents beneath the ocean floor, the planet constantly refills what the sun takes away. The ocean isn't losing water. It is participating in the greatest circulation system in the solar system, a cycle older than life itself, and one that will continue long after we are gone.